In our earlier video, we have already discussed question 1 and question 2 of the 0620 question paper 42 of the examination series October-November 2024. And in this video, we are going to discuss question 3 and 4. But before that, let me show you the other part of whatever I have already described in our earlier video, that you can download the IGCSE chemistry app from this website very easily, where you will get ample resources to practice. So now let's go ahead with our questions. Here is question 3. Now sulfur forms two chlorides P and Q. Now chloride P has the formula S2Cl2 and chloride Q has the formula SCl2. Now both the chlorides are covalently bonded and have a low melting points. Suggest in terms of attraction between the particles why these chlorides have low melting points. Now in terms of bonding and particles, we can say that these molecules have simple molecular structure, and there is weak forces of attraction between the molecules, weak forces of attraction between the molecules, and that's why they have low melting points and a low boiling point. So this is how you can describe for the 2 marks. Now if you go with the B part, it says chloride P, that is S2Cl2, forms when sulfur reacts with chlorine. Write the symbol equation for this reaction. Now when sulfur is S plus chlorine, that is Cl2, that forms S2Cl2. Now if you balance, sulfur is here in the 2 position, so let's add 2 with the sulfur to balance it, and this is the equation. Let's see what's the question C. Yes, complete the dot and cross diagram in figure 3.1 of a molecule of chloride Q, that is SCl2. Show outer electrons only. Now we know that the sulfur is in group 6 and it has 6 electrons in the outer shell. So let's draw 6 electrons, but we know that if sulfur has 6 electrons in the outer shell, it needs two more has to be added, and that comes from the chlorine, that is 1 from each of the chlorine. So if we draw dots for sulfur, then 1 will go for sharing with each of the chlorine, and remaining 4 has to be non-bonding electrons of the sulfur. So total of 6 electrons of sulfur we have drawn. Now chlorine, we know it has 7 electrons in the outer shell, from which 1 will go in sharing with the sulfur, and remaining 6 will be non-bonding electrons in the outer shell. And that is how the sulfur and the chlorine, both of the atoms, both of the elements can fulfill their octet, that is both of it gets 8 electrons in the outer shell. So this is how you are going to draw dot and cross diagram for sulfur and chlorine, that is the chloride. Now chloride P is converted to chloride Q by the reaction with chlorine in a closed system, and the reversible reaction reaches an equilibrium, and this is the equation which they have shown here. Okay, the forward reaction is exothermic, so you can say that this reaction is exothermic, the forward one. Suggest 2 changes to the conditions which will result in a decrease in the concentration of chloride Q at equilibrium. Chloride Q will decrease. Now how? We know that it's an exothermic reaction, so increasing the temperature will favor the endothermic side, and that is the reversible side, and that's going to decrease Q if it favors the reversible endothermic side. So we can, one of the factor which we can write is increase in the temperature. Increase in the temperature is going to reduce the concentration of Q because it will favor the endothermic, that is reversible side. And the second factor can be that a decrease in the concentration of reactants, decrease in concentration of reactants, that is, you can write in the bracket S2Cl2 or the chlorine itself. That can also happen, or you can specifically write the name of the reactants, that is also acceptable. So these are the two factors that's going to decrease the concentration of the product. Now the E part is the rate of the forward reaction in D is determined by collision theory. The rate of reaction depends upon two factors, and the two factors are the frequency of the collision between the particles and the proportion of collisions which have energy greater than or equal to the activation energy. Now define the term activation energy. If you define the term activation energy, so it is the minimum energy required by particles to react, if they have energy lower than the activation energy, the particles may collide, but the collision may not be successful and it will not react. So second part is give the symbol of the activation energy, and the symbol of activation energy is EA. So here is that. Now third sub question, complete table 3.1 to show the effect, if any, when the conditions are changed. Use only the words increase, decrease or no change to show the effect. Now let's see what is the effect on the frequency of collision between the particles and effect on the proportion of collisions which have energy greater than or equal to the activation energy. Okay, we are talking about the collisions which have energy equal or greater than the activation energy. That shows that the collisions which will turn into successful collisions and will make the particles react here. And here the effect on the frequency of collision. So how many number of collisions per unit time is possible? That is the frequency of collision. Now let's see. Concentration of chlorine is increased. Of course, if the concentration of chlorine is increased, the number of frequency of collision will increase, because if the particles have increased, the frequency will also increase. But now here on the proportion of the collision which have energy greater than or equal to the activation energy, that will have no change, because the activation energy value does not change. So only the particles having energy more than or equal to activation energy will only react. So no change here. Now if the temperature is increased, then of course the movement of the particles increase, and that's why the frequency of the collision also increase. So number of collisions per unit time will increase. Now what about the proportion of the collision which have energy greater than activation energy? Yes, what I say is, if the temperature increases, the number of particles having activation energy increases. Number of particles having activation energy increases, and that's why the proportion of the collision due to it also should increase. If the catalyst is added, then it lowers the activation energy when the catalyst is added. So again, the proportion of the collision should increase because the activation energy value has decreased. So here also it is an increase. Let's see what's the next part. Next part is the reaction of chloride P with chlorine is a redox reaction. Here is the reaction given. The oxidation number of chlorine in chloride P and chloride Q both is -1. So chlorine here is both -1. But we should know that the elemental chlorine should have the oxidation number as 0. So here is what's the fact. Now let's see what is the part. Use oxidation numbers to explain why sulfur is oxidized in the forward reaction. Now if you calculate the oxidation number of sulfur here, then we know that chlorine is having the oxidation number of -1 multiplied by 2 because there are 2 chlorine. We don't know what's the oxidation number of sulfur, so we write it as 2x. Now both of it is equal to 0, and this gives us the value of x is equal to +1. So here sulfur is +1 oxidation state I'm writing here, and here if you find out in the similar way, you have sulfur in the form of oxidation number +2, right? So you can say that the oxidation number has increased, and so sulfur is oxidized. So let's write that the oxidation number of sulfur has increased from +1 to +2, and so it is oxidized. Now what I suggest is, if you have looking at the marks, it is 4 here, that shows 2 for each of the question. Now if it carries 2 marks, you need to specify the oxidation number increased from what to what, and that's when only you get 2 marks, because just writing increase in the oxidation number will give you only 1 mark, which you don't know. So you need 2 marks, so specify and quote the oxidation number also. Now the next part is chlorine is oxidized in a reverse reaction. Reverse reaction means going from here to here. Now we know that the -1 has stayed -1 in the compound form, but in the elemental form chlorine is 0. So you can say that it is oxidized because the oxidation number of chlorine has also increased from -1 to 0, and so it is oxidized, and so it is oxidized. So that's how you're going to explain the oxidation of chlorine. Let's see what is the next question. Next question 4. Yes, here silver bromide, that is AgBr, is made when aqueous silver ethanoate. So here is CH3COAg is added to aqueous sodium bromide, that is NaBr. Now understand, this compound is added to sodium bromide to form silver bromide, okay? And the equation for the reaction is shown here. This is the equation, okay? Fine. The method includes the following step. Add 200 centimeter cube of 0.05 moles per dm cube of silver ethanoate to a beaker. This volume contains 0.01 moles of Ag plus ions. Now we should know that it is 0.01 moles of Ag plus is already given. Fine. Now the step 2 is add 50 centimeter cube of aqueous NaBr. This volume contains 0.01 moles of bromide ions and a precipitate forms. Filter the mixture. Dry the solid residue until all the water is removed and record the mass of the dry residue. Complete the ionic equation for the reaction by missing state symbols. Now we know that the silver here is in aqueous form because that's what we have taken in beaker. So we have to write aqueous also, and for NaBr, that is sodium bromide, also we know that it is aqueous. So we have to write aqueous here for the bromide ion also. But the precipitate formed is AgBr, and we know that is precipitate. Precipitates are always solid, so write S for silver bromide, right? Now the B part says name a different aqueous silver salt which could be used in step 1. Now if we know step 1 Step 1 is where we have used silver ethanoate. Now what are the silver salt which we can use is silver nitrate. That's the most common aqueous form of silver ions that can be used commonly. Okay, use the information in step 2 to calculate the concentration of aqueous NaBr. Now step 2 information is that 50 centimeter cube of NaBr is used and this volume contains 0.01 moles of bromide ions. Now if we know the moles and the volume, we can calculate the concentration because concentration is equal to moles upon volume. So 0.01 moles of bromide ion upon the volume, which is 50 centimeter cube, but then we need to divide it by 1000 to change it to dm cube, and so on multiplication division we get 0.200 moles per dm cube. So our answer is 0.200. Let's see what's the next part. Next part is state the color of the precipitate which forms in step 2. Now the precipitate formed is silver bromide and the silver bromide have the color as a cream precipitates. Cream precipitates are seen, so the color is cream precipitates. Okay, let's see. Yes, the next part is use the information in step 1 and step 2 and equation 1 to determine the number of moles of silver bromide formed. Use this value to calculate the mass of silver bromide formed. Okay, it shows first calculate the moles of silver bromide formed from step 1 and step 2. Silver bromide moles from step 1 and step 2 we can show that yes. Okay, step 1 and step 2 shows that we are using a silver sodium bromide of the particular volume and the concentration, and 200 centimeter cube of these silver ions are also used, which contains 0.01 moles of silver ions. Now if silver ions is 0.01 moles, then the silver bromide will also be of the same, because the ratio of silver ions and silver bromide is 1:1 ratio. So whatever is the moles which are limiting, that is going to form the same moles of product. Okay, the bromide moles we have calculated, it is 0.20, but then that shows that it is excess. So silver ions are limiting, and accordingly the moles of silver bromide form. The limiting reagent will decide what product is going to form. So 0.01 moles will be formed for the, you can say, silver bromide moles will be 0.01 because of the same reason. So moles of silver bromide and silver ions are same. You can write that here in a simpler terms. AgBr is equal to 0.01. Yeah, that's how you can describe. Now calculate the mass of silver bromide. For that we need to calculate the MR of silver bromide, that is AgBr, and let's see what is the mass of silver and bromine from the periodic table which is given to us at the end of the question paper. Yes, here is the periodic table. I have rotated the periodic table for you, and the mass of silver we can see it is 108, and for bromine it is 80. So if we add both, that is 108 and 8, so we get the MR of silver bromide. So it's 108 plus 80, which is equal to 188, and now the mass is equal to moles into MR. So the moles is 0.01 and the MR is 188, and that's why on multiplication we get 1.88 gram of mass of silver bromide. So this is how you're going to calculate the whole mass of silver bromide and moles of AgBr. I hope the explanation is very clear. Going ahead with the F, it says name the salt dissolved in the filtrate in step 3. Now let's see what is step 3. Step 3 says filter the mixture. Now the salt which is dissolved in the filtrate. So now we know that this silver bromide is a precipitate and it is solid. So whatever is in the solution in the aqueous form in the filtrate is sodium ethanoate. The other product which is formed sodium ethanoate. So let's write that name the salt. So name is sodium ethanoate. Sodium ethanoate. We need to write the name. Remember, they have not asked us the formula, so name sodium ethanoate. Now the G part is the recorded mass of the dry residue of step 5 is greater than the mass calculated in E because a step is missing from the procedure. Now suggest the missing step. The missing step is that we need to wash or rinse the precipitates with distilled water. The reason is that the residue or the impurity should get washed off, then only we get the pure precipitates of silver bromide. But here if we didn't wash, we might have some other residues also stuck to the precipitates, and that's going to increase the mass, and that's why this calculated or the recorded mass in step 5 is greater. The second part is name the substance responsible for the greater mass of the dry residue. Now obviously the other product is a sodium ethanoate, and that's what the sodium ethanoate molecules are stuck to the product to our main precipitates, and that's why the mass would have increased. Let's see what's the next part. H question here. Okay, barium sulfate can be made by the same method but with different aqueous solutions. So aqueous solutions which we have mixed here in the earlier part should be different. Now suggest 2 aqueous solutions which can be added together to make the barium sulfate. Now the first thing is that there should be 2 solutions, one carrying the barium and the other carrying the sulfate, and both the compound which we name should be soluble compounds, that is in the aqueous form. So the most common aqueous form of barium is barium nitrate or barium, you can say barium chloride also, barium nitrate and barium chloride, and other sulfate solution, any sulfate solution which is soluble. Now we know that all the group 1 compounds are soluble, so you can name as sodium sulfate also, you can name potassium sulfate also, or you can name sulfuric acid also because that carries sulfate in the aqueous form. But yes, we are writing sodium sulfate, that's also fine. The second part is write the balance symbol equation for this reaction. Now if we are mixing barium nitrate, we should write the correct formula of barium nitrate, that is BaNO3 twice, plus sodium sulfate, so Na2SO4, that is sodium sulfate, both in the aqueous form. So we are writing the state symbol also, but I think that's not really needed because they haven't mentioned it, but it carries 2 marks, so let me be on a safe side to write it. Now we know that barium sulfate is our precipitate, so we write barium sulfate in the solid form, and the remaining compound formed will be sodium nitrate. The remaining 2 ions will combine to form sodium nitrate, but we should add 2 to balance it because otherwise the reaction is unbalanced. Again, this is aqueous form. So this is how you're going to write the whole equation balanced. Yeah, so here question 4 also ends, and in our next video we'll discuss the remaining 2 questions. I hope the whole explanation was very clear.